this video, we're going to look at building cohorts with Atlas using an example of chronic kidney failure. We're going to begin by defining a chronic kidney disease cohort, and then we're also going to use that cohort in an incidence rate analysis in Atlas. So let's go over to the Stanford Atlas instance. I've logged in here, and we can see we're on the cohorts page. So the place to start when you're working with building cohorts is to first build a concept set. You might build one or more concept sets depending on the type of domains that you're interested in. A domain might be the condition domain or the measurement domain or drug domain. So if you want to capture, if the definition of your cohort, the people that you're interested in, involves data elements in multiple domains, you definitely want to separate those concepts that you're interested in finding into different separate concept sets. In this case, we're going to look for chronic kidney disease, and that's going to be a condition. I might also think about other ways I might capture patients with chronic kidney disease, maybe based on lab tests or drugs that they're taking, but that requires some clinical knowledge about the area that you're studying. So I'm just going to do a simple approach and just look for chronic disease in the condition domain. So we'll just search the vocabulary for chronic kidney disease and see if we have one or more concepts in the OMOP vocabulary that matches this. So here we have the search results. The blue concepts are standard concepts. So these are how data is represented in the OMOP Common Data Model. The red concepts are non-standard. So you typically don't use these to create cohorts or create queries in the Common Data Model. And these are stored in the source concept ID field in the OMOP Common Data Model tables. The search results are sorted by descendant record count. This typically gives you a good idea of which concept to choose, because you want the concept that has a large number of descendant record counts that shows up in your data frequently. And what descendant means is that this is counting all records that match this concept or anything that rolls up to this concept. So this concept has descendants, maybe more specific instances of chronic kidney disease. And if we count all those up together, we get 913,000. 216,000 of those are exactly this concept, but many more are descendants of this concept. And this is a standard concept, which we know because it's blue. And it's from the SNOMED vocabulary. So this is what we're going to choose here. And we'll just copy the concept ID so we have it. Let's go to concept sets, and we'll create a new concept set called chronic kidney disease. And so to add concepts to this concept set, we'll go back to search. And we can search again for chronic kidney disease, or we can, oops, I guess I did not copy that. You can also paste the concept ID into the import dialog box here. we'll just search again. So here is our concept that we want to include in our concept set. We click this little cart button. And we could click multiple other cart buttons if we wanted to. I'm just going to stick with this one, but we can search again and add more. This little tab up here tells us that we're currently building the concept set for chronic kidney disease. And if we click that, now we're back into the concept sets section of Atlas. And we know, and we can see we've imported this chronic kidney disease concept. So we'll click descendants, and this will include all descendants of this concept. And we can take a look at what's been included here. So this includes a lot of more specific concepts that we're going to consider are also chronic kidney disease. All right, we'll save that, and we'll close it. So X is closed. Once we have our concept sets, these are sort of the base level building blocks, kind of like code sets. We're going to build our cohort definition. So we're going to call this chronic kidney disease. And we'll add our initial event. So every cohort needs to have an initial event that signifies the entry of a person into the cohort. So what causes someone to enter into the cohort? And we're going to say it's going to be an occurrence of chronic kidney disease. So we're looking in the condition domain. Here we can add different criteria for different domains. So we'll look in the condition domain, and instead of looking for any condition, we want to import a concept set. And here's the concept set we just created. We'll import the chronic kidney disease concept set. We're going to look for the earliest event for each person. And we're not going to have any inclusion criteria. We could also only restrict the cohort to people who have observation time prior to or after chronic kidney disease, but we won't do that here. And then when does someone exit the cohort? This is going to be just whenever we stop observing them. So once you enter the cohort, you stay in the cohort until you're no longer under observation, until the continuous period of observation ends. So these are the parts of the cohort definition, and we're just going to keep it really simple and stick with that. So I'm going to save it, and then we'll go to generation. You can also see the concept set that is included in the cohort. So then to generate the cohort, this is the process of finding the patients that are in the cohort. We can just click generate button. So I'm going to generate it on the 1% sample of the STAR database. Here we've got two different database systems, BigQuery and Postgres, so you can use either one. I'm going to close that, and so we just created a simple definition of a cohort, and I actually have already generated a cohort that is exactly the same as this that we can look at. One thing you might want to do is actually search the cohort library that's in Atlas to see if there is an existing cohort. And we can see that we have a few chronic kidney disease cohorts that have already been created. In addition, these start with PL. So this means they're part of the Odyssey phenotype library. And this number after PL is the unique identifier for the for this cohort. So in the ID here that we have is the unique identifier within the OMOP, the Stanford Atlas instance, but the identifier after PL is the unique identifier within the entire Odyssey community. So this lets us kind of refer to this exact same concept, the exact same cohort definition, regardless of which Atlas instance we're using. So if we look at this cohort, chronic kidney disease prevalent cohort, first occurrence of chronic kidney disease in concept set, this is one definition, and then another one is where we take the first occurrence of a referent concept study in descendants. So this is actually exactly the same as what we did previously. You can see we're not able to edit this because this is a read-only cohort definition, but we can read the text description. People having any of the following: a condition occurrence of chronic kidney disease for the first time in their history, and no restriction on continuous observation, earliest event per person, and they exit the cohort at the end of observation period. We can take a look at the concept sets in this cohort, and we see we've got our top level concept set and all descendants, and this has already been generated on the STAR database and the Optum database. So pretty quickly we can see how many patients we have in these two databases using this cohort definition. If we wanted to modify it, we could click the copy button, and now we have a new cohort that is a copy of this existing one. We can edit it, make changes to it, and save it as our own cohort. Let's take a look at this other chronic kidney disease cohort from the phenotype library. And if we look at the definition, it looks quite similar, a condition occurrence of chronic kidney disease. However, if we look at concept sets, we'll see that this concept set has a lot more going on. So we're including, we're excluding some concepts, and we're including other concepts. So this concept set was created by someone with clinical knowledge of the domain, and they were able to decide that, say, this concept here should be included, and this concept here should be included along with all its descendants, and there are other concepts that should be excluded along with their descendants. So this process can be kind of requires clinical knowledge and can be time consuming. However, there is a tool to help with this called Phoebe. You can reach it at data.odyssey.org/Phoebe. And this is like a concept set recommender system where you start with some sort of search string and an initial domain that you're interested in looking at. So here I search for chronic kidney disease, and it recommends that I use this top level concept set or concept. When I add that to the when I input that concept into the concept set recommender and say show recommendations, it will recommend 193 other concepts that it thinks I might want to consider including. And so I can go through these, and if there's any that seem relevant to add, I can add them up here and continually refine my concept set that way. I won't go over the details of how this works, but there is a nice presentation on the Odyssey website that describes how this works. So now that we look at, now that we see that there's two different ways we can define chronic kidney disease, we might just compare the number of patients in each cohort. So let's think about using these two cohorts in an incidence rate analysis. And in this case, I'm going to choose a simple outcome, maybe the ultimate outcome, death, and we're just going to look at the incidence of death in each of these two cohorts. Now, to create a new incidence rate analysis, I would just click New Analysis. I've already created this one, and we can add target cohorts. This brings up our list of cohorts. The target cohorts are the denominator, and the outcome cohorts are the numerator. So I've added two cohorts from the phenotype library, the different chronic kidney disease cohorts. And our outcome cohort is death. This also comes from the phenotype library. The time at risk is the time after the cohort entry, which we're going to consider to be the time available to observe the outcome. And here I've chosen 3 years, or 1,095 days. We can also stratify or add a study time window. So if we're only looking for, say, the last 3 years or last 4 years, we can add that here. Once we've added our target cohorts, the denominator, and the outcome cohorts, the numerator, we can generate. So generation is just as simple as clicking these buttons next to each database, and we can see that we've generated it on the Optum and STAR databases. And so we can kind of compare the different incidence rates between the two databases. We can also compare the rates between the two cohort definitions. So we can see that this cohort definition includes many more people. The first one, we've got 63,000 or so, and this gets us up to 76. Our rate is 36 in STAR per 1,000 person years, and the rate's a little bit lower in the second cohort definition, but it's similar. What is kind of surprising is the difference between these two between the two databases, and that might have something to do with the characteristics of the database, in particular the age of the people in the database. And that concludes our look at the chronic kidney disease cohorts and running an incidence rate on and looking at the incidence of death in both cohorts on two databases. In the next video, we'll take a look at the prediction function and how to build a patient-level prediction model to predict death in each of these cohorts.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. please visit us at med.stanford.edu.